Hey, how's it going? I am Brandt Hughes, the editor and camera operator of Modern Rogue, as well as, other stuff. And maybe recently you have seen our TAC video. If you haven't, then this isn't going to make a whole lot of sense, so you should watch that.
TAC. TAC, and it's pretty bad.
Ooh.
It's pretty bad.
All of you were asking me to show you how I made the overlay. Okay, well, maybe just one of you asked that. But you know what? That's enough for me because I'm proud of it and I think it's cool. So I'm just gonna show you how I set that up and how I programmed it. And maybe that's enough for you. Maybe you just want to see some of the hard work that goes into a video you enjoyed. And if so, I appreciate that. So this was all done in After Effects. Of course, the cutting of footage and everything was in Premiere, but this overlay system I made in After Effects. There's a lot of JavaScript involved. There's a lot of keyframing involved, but I will just sort of walk you through it. You can see it over here. There is so much scripting involved, in fact, that occasionally After Effects will just become unresponsive and it'll really get throttled from all of the scripting processing it has to do. First things first, you have to do some iterative design because a lot of this is about communicating to the audience. You're communicating rules, you're communicating possibilities. If we look at some of the early versions of this, the optimal pathways to a road victory are far less clear. The stat counts are far less clear. That's just something that you have to work on because as an editor, you have the power to clarify information and you have the power to confuse information.
5, 6, 7, 8. That would be a tie. That'd be kind of boring.
You have to be very careful about that because if you do a bad job with this overlay, it will be worse than if you did nothing. So first things first, you have to do that. You have to kind of figure out what's the best way to communicate things. We'll start from the top down here. It's important to keep track of how many stones they have available to them. Stones are, of course, names for the board pieces. So I didn't label what these numbers meant, but I hope that it became relatively clear what they meant as you watch the game progress. It was important to keep track of how many tiles they had remaining because they only have a specific amount of tiles, and if you use all of your tiles, the game ends. You start with 21 tiles, which is this number on the right here. This is just a text layer that I typed the numbers into, and we're already gonna reach our first bit of scripting here. If I change this to 5 tiles remaining or so, we see that this bar automatically fills up. If we go to 0, that bar goes all the way to the end. Very cool. It's automatic. That's helpful. Okay, so here's our keyframes here. And we can see that this is a hold keyframe. I think with text, it can only be a hold keyframe. Yeah, so that just means that there's no animation. It just, boom. If I wanted to animate this number to change or something, I could have done something like adding an expression control using a slider, sliding it from 21 to 17 or something like that, and then keyframing that, having the source text refer to the slider control. I could have done that. I found that with a lot of these board game overlays, I tend to try to minimize animations. My compulsion is always to animate everything and make everything look smooth and nice and organic. But with these board game animations, there are so many keyframes. If we just open up all of our keyframes and we look at everything here, this is the first game. There are so many keyframes that you have to juggle that I want to minimize the amount of keyframes. And anytime you have animations, typically that means more keyframes. There are ways to do animations with fewer keyframes, but that's complicated and I don't want to get into that. So I tend to just do snappy cut to sort of animations here. Now, how does this work? Well, let's take a look at it. So we can see this bar here is just one shape layer, the whole thing. So yeah, if we go into this shape layer, we can see that we have the active tiles here, which I'll talk about more in a minute. We have the amount of tiles that are in play, and then the background, which acts as the amount of remaining tiles bar effectively. And then the box Yeah, I mean, these two are basically the same. The box I wanted to have like a thicker stroke around the edge than these sort of interior boxes. That could be relabeled to border or something like that. Okay, so the thing that is scripted here is this in play box, which you can see here. I want it to be a little bit darker so that way you sort of indicate that this is like an inactive property and this is an active property. This is the one that you really want to pay attention to, but it's useful to understand this as well. If we go into it, we have two properties here that are scripted. I'll talk about anchor point first. So in order for this to work, you want the anchor point to be on the far left side of the box. So what our JavaScript here is doing is it is referring to the size. It's paying attention to the size. So it's setting the anchor point to 0 in the y-axis, so up and down, which means that it's centered in this particular case. That's not really important, whether it's center, top, bottom, anything like that. But in this case, it just felt right to have it centered. But then our x-axis is basically saying 0 minus half of the width of the box. So if the anchor point is typically 0 dead center, and then it moves half the width to the left, then that means that the anchor point is always going to be on the leftmost edge, no matter how big the box is. That's really useful because that means that whenever we change the size, right, and we change the size like this, the size increases, but it stays anchored to the left. So that way it just extends further and further out to the right. So let's go ahead and take a look at the size, what the scripting is here. This is also a relatively simple script. What we have here, we're referring to remaining. So that is the text layer here. So it's reading this text. We have an X value and a Y value. The Y value is just saying whatever is input. Right, so that allows me to actually change the height if I wanted to, and it will preserve that. There's no real reason for that. I just kept it referencing itself so that way I have the flexibility to change it if I needed to for some reason. So for the x-axis here, first we reference the input value, which is 1200 pixels. That's the full width of this entire box. If we look over here at border or background, it will be 1200. I could have just directly referenced this property, but you're going to see that we have so much scripting in this composition, in this timeline, that you really want to minimize as many script calls as possible just to keep it performant. I guess it probably would have been slightly more performant to just type it in hard-coded, but sometimes you want to maintain a little bit of flexibility. So we're going to divide 1200 by 21 because they're going to have a maximum of 21 tiles. So that basically gives us the width of one tile on this bar. Then we multiply that by 21 minus however many remains. The remain, of course, is pointing to this number. So 21 minus 17 is 4. So 4 times this one tile width. And we see that now it is 4 tiles wide. And it's nice because, you know, even if you get to 0, it's going to fully fill up the bar. If you have it to 21, it's going to fully drop the bar. In this case, it's behind the active bar. That's how this bar works, the in-play bar. But we have this number over here on the left. I put some text on screen that defined what this number is. Hopefully that was clear. I had a hard time figuring out like when and how to clearly specify that. But this number is how many exposed flat tiles are on the board for this player. So if it comes down to a flat win count at the end, this is the number that we're referencing. And this does not include capstones. This does not include walls. It does not include flat stones that are covered by being inside of a stack. So if we see that we change this number, it also, updates the width of this active bar. So you'll see a pretty similar situation here with this active road block, this active road bar. We have scripting in the size. We have scripting in the anchor point. Well, it's going to be pretty similar here. This anchor point basically sets the anchor point to the far left. Okay, I don't need to go over that any more than I already have. And then the size does the same thing as the other one, except now it is referencing this number rather than this number. It's also worth noting that, we're converting this from a string to a number. If we had done the technique I had mentioned earlier about using an expression control like a slider control, I think we could reference this without having to convert it to a number, because by default it is stored as a number data type. But in this case, we're just reading a text string, so you have to convert that to a number if you want to do math with it. So that pretty well explains the bulk of this bar system. So I had to figure out what to do with the capstones, because the capstones are treated a bit differently than the tiles. It would be confusing if I set this to 22 and one of those numbers represented a capstone, which is a totally unique piece. And also the capstones don't count for a flat win. I needed some way to set it apart from the stone count. So I just have this 3D render that I made in Blender of the capstone. And then here, I just keyframe the opacity. I set it to 20%, so that way you can see that it's there, but it's clearly inactive. And then I set it to 100% when somebody has put it into play. Just so that way you can kind of visually identify when a capstone is in play and when it's not. For Brian stones, exactly the same thing. Obviously, just using its own layers. And you can see we've got a bunch of layers here, and I will get to these as well. There's a lot going on here. I had a very busy week keeping track of everything. Okay, so we're going to keep going down this board, and we have a momentum counter. This is supposed to be a counter that indicates how many moves you can optimally make to win. For instance, here, Brian, in the blue tiles, can place a tile here, and a tile here, and all of a sudden, he conducts from north to south, and boom, you have a road win, 3 moves. These bars are also automated, so if I set it to 1, it shifts over. If I set it to 10, it shifts over this way. So there's really a push and pull kind of effect going here. I really wanted to indicate that when one of these gets closer to 0, that bar fills up most of the space to indicate that that person is very close to winning. But I have to reference both numbers, because if this person has 1 move left to win and this person has 1 move left to win, well, they're both equally close to winning. There are a few things that are not factored into this. For one, it doesn't factor in whose turn it is. In such an instance where both players are 1 turn from moving, the person whose turn it is now probably has more momentum and is actually closer to winning. I don't factor that in. This bar is pretty closely related to a lot of these road paths, these optimal road paths, and I'll talk about that in a minute as well. But I didn't get a chance to note this in the video, but it's worth noting that all of these I just did manually. I did not have like a computer program that analyzed the board and figured out the optimal paths. So there are probably some instances where I missed an optimal path. Maybe I had a miscount. It could happen. I haven't seen any examples of that yet, but I'm sure someone will find them. Also, it's worth noting that when it comes to these numbers and these road paths, I'm just considering the board in its current state, locked into its current state. So in this case, Brian is 3 from winning. Right now, there are no capstones on the board. So I'm not considering what is the optimal path if you are to play a capstone, because that's not the current state of the board. Similarly, I'm not factoring in an opponent's move. I'm saying 3 moves, assuming your opponent does nothing, just omits their turn somehow, which is not really how the game is played, but I feel like that is a simplified perspective that was much easier to follow than if I were making some wild predictive optimal paths that says if you play a capstone and your opponent blunders and these things that are hard to visually see on the board right now, yeah, maybe you can finish in a move or 2 fewer. So just know this is not strictly like a computer optimized analysis of the optimal paths. This is just what I saw as the optimal path at the time. Just wanted to clarify that. Okay, so how does this bar work? Well, let's dig into it. Okay, so we've got this bar down here, fewest moves bar. We can see there are 2 expressions. We have 3 bars. One is just the basic background. I kind of set that to sort of block out the shape. And we have a Brian bar, which the Brian bar is always fully active. So actually, I probably don't even need this sort of box. It's, again, just sort of used for the border. And then we have the Ryer bar. And the Ryer bar is, I think, the only one that has, the Ryer bar is the only bar that is actually scripted, the only bar that is actually changing, and it is just revealing more or less of the blue bar behind it. So the anchor point, as you can imagine, if you've been following along, you can probably guess that, yeah, it's just scripted so that way the anchor point is always attached to the leftmost side. This allows the right side to move back and forth. Now, what is the size? The size is going to be slightly more complicated than before, but not by a lot. So we are taking R, which is Ryer's number, this one here, and B, which is Brian's number here. We're converting these text strings to numbers. So it's seeing the number 1 and the number 3. For the Y value, that is just input value again. So nothing special going on there. And then for the X value, we have the full width, so 1200 again, divided by R plus B, so in this case 4, times B. It's basically seeing that there are 4 moves total across both optimal plays. And it's saying, okay, so across 4 units, Brian is 3 from winning and Ryer is 1 from winning. So we're going to extend Ryer's bar out 3 units to show that he is that much closer. It's kind of inverted from how you might typically expect to use the numbers, but I feel like it was more clear to show a bigger bar for somebody who is closer to winning than a smaller bar for somebody who is closer to winning. But if we just change this value to R, this is more immediately representative of the numbers available. This is just kind of how you'd expect it to be. Big number equals big bar, small number equals small bar. To me, this feels like the bar is almost all of Brian's color. This is almost all blue. So it feels like blue is about to win, just in my brain. Maybe you feel differently about it. When you make your overlay, you can change it how you see fit. Now, before we get to the real meat of this system, the board, I'm just gonna make a quick note here. I included diagnostic time. Diagnostic time, you can see here, I've scripted the source text to basically just output what frame this is on. So we can see here, it's frame 2090. This was important once I had started making things because basically this composition gets imported into Premiere. And if you make any cuts to the footage in Premiere, either your animation, which these lines are animated, either you're going to see a jump in the animation here, or you can slide over the composition to basically make it smooth again, but then all of your sync gets thrown off because you cut a bunch of footage out. So I use this as a diagnostic to keep track of like, okay, a piece appeared on this frame, but it should have appeared on this other frame. So let me come back to After Effects. Let me look at the keyframes. Let me find the right keyframe. Let me go to the keyframe it was supposed to appear on and then drag it over. That's just like a way that I use to keep track of when things happened and when things should have happened. And then of course I disabled this when I rendered out the video because you don't want the audience to see that. That is just a diagnostic thing. I could have maybe also set this as like a guide layer or something so that way it doesn't actually render, but I just thought I would mention that that's a thing. Okay, so the board, here's how the board works. It's a lot. First, we have just the board itself. This is a shape layer with, we start with the box just to sort of block out the shape. Then I established a grid. A grid is just a square here with a border, and then I have 2 repeaters, 1 repeater to extend out a full row, and then 1 repeater to extend out all of the columns. Nice and simple, nothing too complicated there. Then we have the crosshatch. Similarly, I made a box here. I repeated it and then rotated it to make the cross. And then I made a repeater again to fill out the row, a repeater again to fill out the columns. Then we have the border. Very simple. It's just a box the size of the whole board, and it's just a thicker stroke so that way it stands out against the background. That's the board. Now, how did I handle the pieces? So there are 2 ways to deal with this. One is to create 21 white pieces and 21 blue pieces and then move them around and do all of that. I didn't like doing that because I feel like it would be very easy to get confused about things and it would just be hard to keep track of. So instead, let's go ahead and look at B1. Forgive the fact that I didn't use like chess notation here. The columns are labeled by a letter, just like chess notation, but my numbering is backwards. Typically you start 1 at the bottom and then you increase as you go up. Here it's the opposite. Okay, so let's look at B2, which is open here. Basically, I've created a capstone. I've created a flat stone, which I labeled road. I labeled these before I really understood the terminology, so try not to get too confused there. So capstone, a flat stone, and a wall. I made all 3 of those shapes. These are indicative of the topmost piece. And then I made an indicator for the stack. I went 6 items deep because we never go beyond 6. I think we never go beyond 5, but I wanted to have the flexibility to go to 6 in the eventuality that it ever got that tall. So I made all of those shapes for each position on the grid. So we're talking about 250 shapes or 225 shapes or something like that. Just a ton of shapes. And then what happens is I created these controls. These controls are known as voids. Basically, they're shape layers that are set to be guide layers so that way they don't render. Voids are a really cool little system that some folks have developed. And so I created a void for each grid position, and they act as a controller. So inside of this void, you can see I have a bunch of effect controls. And each of the shape layers reference their own corresponding controller. So here we can see we have a hide button that hides all of the shapes on that spot. We can control what the top piece is. We can control what the stack shows, which color it is, and whether there is one or isn't one. And then also they move correspondingly to how many there are, so that way it's always vertically centered. I'll talk about that in a minute. Okay, so let's look at B2, which is currently active right here in this whole mess of overlaying shapes. And the first thing that is scripted is in the transform. We have the opacity scripted, and all it does is it determines the ID of this. This was important because I needed the scripting to be relative. So basically what this does is it looks up the name of this group right here. It sees that this is the B2 group. And so the ID is B2. So everything it references can reference that ID. And I can just copy and paste this, and it will reference other things in its name. So that'll make sense in a second. So the input is the B2 controls, and it looks for the hide checkbox, and it sees the value. The value is either true or false. If it's checked, it's true. If it's not checked, it's false. And it says, if hide is true, set the opacity to 0, meaning that it's not visible. If it is false, if it's not set to hide, then set the opacity to 100%, so it's totally opaque. Now, if I copied and pasted this whole group and I set it to B3, well, now this same code. I don't have to change the code at all. I just have to change the name of the group to B3. Now this code is referencing the B3 controls. So it's just a little bit less work that I have to do down the road. That is really useful to keep in mind. This is a slightly more complicated thing. Property group, the way that this works, always confuses me every time I use it. I'm like, how many groups back do I have to go? I don't know. Once you get it set up, then you just don't have to think about it anymore. All right, we have the road. Let's look at the road because the road is actually active. We have two things that are scripted in the road piece. One is opacity. Again, we're using property group. It is referencing this as well, B2. So ID is B2. The input is B2 controls. So we're looking at the controls, and it's specifically looking at the top piece value. So if we look at our controls, it's looking at this value that I have created here. It says road, stone, or capstone. It's worth noting that in my game 2 overlay, I actually fixed all of these. So it's flat, wall, and capstone, but I just didn't have time to like go back through and just clean this up. So it's a little confusing, but just so you know, I know this opacity is looking at whatever I have selected here. And what it's saying is the value, now the value for a dropdown in After Effects is just a number, and it doesn't count from 0 like a lot of JavaScript does. It counts from 1. So if you select the first item in the dropdown, it has a value of 1. If you select the second, it has a value of 2. The third, a value of 3. It doesn't matter what the text is in the dropdown. It's always just the number of that index. So here it's saying if I have chosen the first item in the dropdown, which in this case is road or flat stone in game 2, then set the opacity to 100%. I want to see the flat stone item if I have flat stone selected. Otherwise, set it to 0. So we can see in stone, which is wall, here, it's the exact same code, except it's only being opaque if I've selected the second dropdown. And similarly with cap, it's only opaque if I have selected the third dropdown. All three of these exist, and they're all stacked on top of one another, but at any given time, you're only seeing one of them depending on what I've selected here. And then this is keyframed, so all I have to do is I just scrub through, find a frame where something changes in the footage, and then I go, okay, well, that is now a wall. So I just change this, it automatically sets the keyframe, and I can keep moving on. It will stay what it was before until that frame, and then it changes. Really useful stuff. Now, what is the second script in each of these items? Well, the color, of course, because we need to know which player it corresponds to. So what do we have here? It's starting to get a little bit more complicated. So our ID, we're starting off with the ID. We have to know which controller to reference. So it references B2. Then it says, okay, input is our B2 controls, but specifically now we're looking at color value. So let's take a look at that. Color here. Now we could have done something like a color control, which would have been convenient and useful, but we very specifically are only using 2 colors, and they're always the same 2 colors, so it sort of isn't useful to remember the hex code and have to paste in exactly what it was or click around or whatever. Instead, it's simpler this time to just keep it as a dropdown. So here I have a dropdown where option 1 is white, option 2 is blue. So remember that because it's looking at the value, input is always going to be a number, and that number is going to be 1 or 2. What is P1? Player 1. So player 1, this is referencing general controls, which I have not talked about yet. That is this void up here. General controls, I made this void to just be something that everything can reference if it needs to. So here I have inserted player 1 color and player 2 color. This allows me to quickly and easily iterate. So if I come in here and I change this to purple, let's say, all of a sudden, all of these pieces change to purple because they are all referencing this color. Now, when I made this, I didn't actually make the bars here, the stone count or the momentum reference these colors. So they don't change, but they could. They easily could if I used the same code. And so now all of a sudden, this changes color. Really nice to have that possibility to change things. I specifically made this because originally these cyan colors, they were a purple color. But I found that the legibility wasn't so great with purple. It just is a little too close to my eye to this medium gray. So I wanted to iterate on that, and then I found cyan pretty quickly and didn't change it further. But in case I did, if I changed my mind later on, I wanted to be able to just have a controller here, change it, and then it propagates through all of the items on the board. So here, player 1, it looks at this color. P2, player 2, it looks at this color. Then it says if input 1, color, right here, this drop down, if it is set to 1, set the color of this piece to the color, the generalized color of player 1. Otherwise, use the color of player 2. So it's a super simple if else. I use a lot of them throughout this. So that's a very straightforward. It's worth noting sometimes it gets a little tricky when you're messing with color values. Sometimes you'll have to like convert between different types of color data. In this particular case, because we are referencing this color expression, it is just the straight up color value and we don't have to do any converting. It just says, look at this color, which is very convenient to do. Otherwise, we might have to use one of these sort of array conversion methods, which it's kind of a lot to deal with. Okay, so that is all of the scripting in road, stone, and caps. Now let's look at stacks. So we have 6 stacks. How much scripting do we have going on here? We have 4 scripts in each of these stacks. And of course, we have 6 stack items per grid spot. And we have 25 grid spots. So that means we have 150 stack items across the whole board. And we have 4 scripts per stack item, which means 600 scripts are running every single frame. Because in After Effects, the script is not able to reference other frames. It has to run it a new time every single frame. So you can start to see, and that's just the stack items. That's not even like the regular pieces. That's nothing else. So you can start to see how it can get really bogged down when you have all of this going on simultaneously. Okay, so what's happening here? Well, first let's start with color because that's pretty simple. It's basically what I just showed you. Yep, it is referencing, the ID name. It's referencing the color of the stack item. We have stack right here. Either it's set to none, white, or blue. If it's set to 2 or 3, that changes the color. Simple. Get that out of the way. Opacity, similarly. And so instead of having a hide button or something, I basically included hide into the color options here with the none value. Again, this is just represented by the number 1 if you call this value. And so basically here we're doing the same thing. We're representing the ID. Don't mind this slice. This slice is just a holdover from how I named it previously. It used to be like B2 and then some other text. And then I just simplified it down the road. So some of this code is a little bit outdated. Okay, so yeah, it references B2. It looks for the B2 controls, and then it looks specifically for stack 1. So it is looking at the name of this object as well, and it's integrating that into it. This could be cleaned up a little bit by turning this into a variable or something, just so it's a little bit more legible. It's saying that if I've chosen option 1, which is none, then set it to invisible, opacity of 0. Otherwise, turn it on, keep it opaque. So now we have 2 position properties that are scripted. So what do we have going on here? I actually don't remember. So I'm gonna find out along with you. X, we start off by defining as the value of the input, -1600, and the input, -26. Then we have the ID, which in this case is B2. We have the stack, which is B2 controls stack count. Right. Okay. So it was important to know how many stack items are visible to know how far the offset should be for each one. So I created a slider here, slider expression, and there is a little script in that. I didn't want to run this script for every stack item because if you remember, there's a ton of stack items throughout this whole thing. But by putting it in the controller, I only have to run it once per grid spot. So basically this starts at 0 and then runs a for loop through each stack item. And the stack items, remember, can be a value of 1, 2, or 3. It says, well, we're going to subtract 1 from whatever that number is. So we're converting it to 0, 1, or 2. And it says, well, if it's anything bigger than 1, just assume that it's 1. Because we just need to know whether it's active or not active. So either it's 0, none, or it's 1, white or blue. And then it adds all of those together, right? So if it's none, it doesn't count towards the stack count. If it's any color, it adds 1 to the stack count. So it looks through and it sees white, that's 2. If we add 1, it'll be 3. If we add another, it'll be 4. So we have a stack count, and the stack count just counts how many items are in the stack, of course, just like it sounds. So we take this stack value and we subtract it by 1 for reasons that will hopefully be obvious in a moment. We look at the Y value. We say, input the value. So the value is basically the default value here. These numbers is basically what I determined is approximately dead center, slightly off to the right, dead center. I think this was just manually placed. And so we have this sort of vertically dead center position. And then 19 pixels is how far apart the center of each of these two stack items are. So each of these are 19 apart. Now, stack 1 is going to be a little bit different than the others, if I remember correctly. But basically, it's saying however many stack items there are minus 1, we're going to, because, and I do minus 1 here because if the stack is 1, this doesn't need to be moved vertically at all, right? Because it's already dead center. So we'll do 19, which is the difference between two stack items. We multiply it by 0, so it's 0. And so it's dead center minus 0, so it stays dead center. But for every additional stack item we have, it will push this topmost stack item up 19 pixels. Okay, and then if we look at position, what are we doing here? Let's see, this property group .name slice -1. Okay, so it's looking at the stack index, basically. It's saying which stack item is this? In this case, it's 1. So it says -1, which means count is going to be 0 in this case. So we're looking at X. I mean, this should probably be Y because X is 0 here. I just kind of defaulted to X because that's a convenient variable name. So X equals count, so 0 times 38, which is 0. Okay, I think this will make more sense once I look at stack item 2. So these are going to have all of the same scripts, so still 4 scripts, but specifically we're going to look at the positions. Okay, I think I see. Why are you like this? Okay, so I think I understand what's happening here. Took me a second to like really look at it and sort of piece together. Okay, so I'll get to that in just a second. So this position here, it's looking at which stack item it is, and then it says however many stack items it is, multiply by 38, and then, basically push that item down 38 pixels. So each of these stack items is actually 38 pixels apart. And so stack item 2, 38 pixels down, stack item 3, 76 pixels down or whatever. So it's basically always keeping these stack items down the appropriate amount from stack item 1, which is always on the top. It keeps them ordered vertically. Now, so this extra position property, for all of the stack items that aren't stack item 1, they are just looking at the position of stack item 1, and it's saying inherit that same position. So basically, whenever stack item 1 moves, all of these move with it. So if we add another stack item 1 moves up, and all of these move up with it, just 38 pixels down from that. Okay, so that sort of keeps them parented to this top item. Now, we notice that here we've got this going on oh, what's the deal with that? Well, 19 is half of 38. So basically, it's trying to keep the center point of the whole stack centered to this main item. It's basically considering every time we add a new item, in order to keep things centered, we don't want to move it 38 up. We want to move it half of 38 up and half of 38 down, just so that way we keep everything symmetrical and synchronized and vertically centered. So that's what it's doing here. That's like a slightly complicated mathy sort of script. And because these are all referencing property group names and stuff like that, there is some unique scripting for stack 1, but stack 2 is iterative. So for stack 2, I could basically just copy and paste down to stack 6. And as long as I change the name of the stack item, it's going to figure out the correct place to put it. And none of the scripting actually has to change from stack 2 to stack 6. Again, we're trying to work smart, not hard, although it is, in this case, you have to work hard to work smart because it's tricky. It's complicated. Okay, so that sort of explains a lot of this. Okay, so I guess the last major piece of this overlay system. Wow, it has gotten dark outside. I've been yapping for an hour. The other major piece of this overlay system is the path sort of network that we have going here. As I mentioned earlier, these paths have been manually laid out, so I did not use any sort of computer analysis to figure out the best paths. The only design downside that I really saw with this that I would have loved to have fixed if I had the time to do so is that sometimes when a bunch of paths cross over the same tile here, it can get a little confusing to see exactly where the paths are because they're obscured. I could have put the paths on top of the pieces, but I think this would have obscured the pieces enough that it would have also caused its own legibility issues. I think given enough time, there is a way to design it so that you can clearly see where each path goes and you can clearly see the pieces, but I just, I had time constraints. It was going to take some time to figure out the best approach to that. So something I did in the meantime is I tried to maintain that if a line goes straight through, you know that it is the same line. When a line needed to be offset, I tried to maintain that it is offset so you can kind of imagine that, oh, this is the one that is slightly off, so it's probably the one that is still slightly off. And that's just like a visual language thing I tried to be consistent with, but, I don't think it's a perfect solution. So over time, that's something you would hopefully fix. There is some animation here. This is the only animation on the board, and I was really pleased with how this came out because without it, all of this feels quite static. These board game overlays, as I mentioned earlier, tend to be static just to keep things simple so that way I can keep track of everything. But adding the little bit of animation brought a lot of life to it and made the lack of animation of the board pieces a little bit more palatable, I think. So these are just shape layers that have a stroke but do not have fill. So it's basically a vector path with handles along the path that I'm animating. This path is set to hold across the board. So that way, similarly, it's not, creating tween frames or anything. It's not animating between one frame to another. It's just holding that frame until it gets to a new frame and then it changes immediately. That's sort of a design aesthetic for this kind of thing right now. But these paths are created by hand. I tried to keep the paths orthogonal. All of the turns are at right angles. I think that helps keep it look very clean, but also helps imply the direction in which these pieces can move. It would be very confusing to not have them as clean as possible. So I have a variety of paths here, and I just, whenever a new piece moves, I try to analyze the board and figure out what's the optimal path. If the optimal path is only one move away, is there only one optimal path? Are there multiple? And I will change the opacity of each of these. Typically, as I'm editing, I'm just looking at the opacity to see that, like, okay, this is the path that's active. If I need to change something, I know I have to change this path. Here, we have 2 paths that are active for Brian, at least. And so this is typically what I'm looking at as I'm actually editing the board. And it helps me note when something actually changes. That's not always strictly true because sometimes a path can stay active, but its path can change. So I either set the opacity to 100% or 0%. I could have done something like the control layers where I have like a hide checkbox or something if I wanted to, because I'm only ever using 100% or 0%. But I just didn't want to have more scripting in the project. I felt like that might have bogged it down a little bit more and I didn't need it. You might notice an offset here, and that is because there is actually 2 paths for each of these paths. And that's how we're getting this animation here. Let's actually go back to the beginning because that's where you'll see it the most clear. Okay, so we have 2 paths here. We have one that's called line cycling and one that's called line. The one that's called line cycling is what gives us our animation. So what happens here is line is sort of the baseline. It's this darker color. And that's the one that I'm actually changing the path of on any given frame. Whereas line cycling, its path is scripted to just reference the baseline. It just inherits whatever changes this line has. It is always constantly matching that line. And so this line is a brighter color. You can see that if we change it here, gross. And then we apply a trim paths, which we can find here, a trim paths property. And what trim paths does is it does exactly what it sounds like. You can make this really minimal and make a quite small path, or you can make this 100% and then it's the full path. Basically, it's taking the path from the very end and it is trimming it down more and more and more. And then we have an offset here. And what the offset does, if I get rid of this, you can see that the offset changes where along the line the end is that it's trimming from. And then it cycles, it loops around. So here it's at 90%. So we're just trimming out the last 10%. So the line goes from 0% to 90%. Here it goes from 0% to 20%. The offset, it pushes along where 0% is and where 100% is. And it is a sort of circular control. So it does 360 degrees. And once you get to 360, it resets back to the beginning. If we go a little bit before, you can see that it loops. So you can see that what I've done is I've keyframed it to go from 0 degrees to 1 full revolution. So it is fully cycled through. And then I programmed it to loop out. So basically at the end of the last frame, it will start referencing the first keyframe again, and it will just go through that and cycle through that animation over and over. So I don't need more keyframes. It's just constantly cycling through and looping this line cycle path. And so that's great. It basically means that no matter what, it's going to constantly be looping. I tried to generally keep it so that way the animation goes from left to right and from top to bottom. But there are instances where it is reversed just because I'm, moving the paths around and sometimes it gets backwards. I don't think that's that big of a deal, but I did try to generally keep it a consistent flow of direction just to be slightly less confusing. Now we have wiggle paths. Wiggle paths also gives us some animation. Without wiggle paths, it's just a perfectly straight line, which is fine. But Modern Rogue has a little bit of an organic, I've always considered the Modern Rogue aesthetic to be a little bit like Cold War era technology, like retro futuristic technology a little bit. It doesn't always shine through, but sometimes that aesthetic plays a factor. So there is always some level of grungy, like old school technology, old school film technique kind of stuff. And I feel like Wiggle Paths gives us a little bit of the hand animated sort of look to it. So what Wiggle Paths does is it takes this path and it sort of modifies it. So that way there is a little bit of a wobble here, but there is a little bit of scripting to it. So I keep it semi-large size and relatively small details. So that way the wiggles are kind of big and vague. I don't want to see really high frequency wobbles. I want really low frequency wobbles that are not huge, but big enough to notice. High correlation basically just means that it stays closer to the line. The lower your correlation is, the less strictly it adheres to the given path. Not a big deal. Corner is important because later on when the paths are taking these harsh 90-degree turns, and without corner, when it's smooth, we get these weird wobbles, which is fine. It's a totally fine aesthetic choice, but it does not lend itself to legibly being this harsh turn, which I really wanted in this particular case. So the animation here is in temporal phase. Typically what you would do is it comes by default with a wiggles per second established, but the problem with wiggles per second is that it is a smoother animation, and I want this to be a kind of a rough animation. So I always animate temporal phase. It is the animation through time, but I have more specific control over it. And this scripting is dead simple. Posterized time basically reduces the frame rate. So this is 3 frames per second, which is like very crunchy, very just like choppy, jittery. It's only updating a few times per second. With Modern Rogue, we also do a lot of stuff with like 12 frames per second, 8 frames per second, 7 frames per second, something like that. Especially with like when assets are kind of jiggling on screen like that. I will posterize the position. I will posterize the rotation as well, just to kind of keep it feeling a little bit analog, a little bit hand animated, that sort of aesthetic. And then we have a random. One thing you might be tempted to do here is do something like time times 1000 or something like that. And basically this will just keep increasing over time, over and over and over again, just constantly increasing. But a problem you'll run into, especially with a composition this large, is eventually, and I think it might be right before it hits 10,000, this sort of rotational control stops working. It'll reach a maximum value and it'll not go higher. So I tend to avoid doing this sort of thing time times something, just because I know that it can reach a maximum value. I've had that unexpectedly show up before, and I don't like that. So instead what I do is basically every time it updates, it picks a random value between 0 and 3600, which is 10 cycles. I find that that is a wide enough range that it's always pulling a frame in time that is far enough apart from each other that it looks like it's kind of getting some noticeable changes without ever exceeding the value here. I mean, you can make this whatever you want. You can make this quite a bit higher if you wanted as well. But for me, that's just easy to remember, and it works pretty well. Okay, and so that is the line cycles. And then, yeah, of course, all of these are just picked by hand. When you have wiggle paths, it's important to try to keep these frames from these path frames from being too close to one another. Because if you do, sometimes you can get some awkward bunching up of the wiggles. But if you sort of spread it out, you will get less of that. It'll be a little bit smoother. That's just something to keep an eye on. It's not the end of the world, but it reduces your polish a little bit. Okay, anything else? At the end, I have this sort of visual aesthetic for defining who won. So I wanted to just really highlight the path that actually connected to the end. And so that is just a simple, like, I have a shape layer that is the same size and position of the board, that is black, that is set to a lower opacity, 60% here, just to kind of fade out all of the other pieces. That is track matted to a path here, and that path is just the shape of the road that won. Real simple stuff. When it comes to board 1, this path also included a bunch of these tiles for the flat win. I felt like that was easiest to communicate. These are the pieces that contributed to Brian winning in this particular instance. Hold keyframes, just like everything else. And then we have these texts that indicate how the person won, and that's just animated with opacity. Nothing too technical or complicated here. And I think that's it. I don't think I'm forgetting anything. The only things I would change if I had more time to do it is I think it would be useful to have some sort of simple animation to indicate that a piece had just moved. So maybe, it briefly changes color or something, or maybe the background of the board changes color for half a second once that piece is moved. Just because when it snaps from one frame to another, you might have blinked, you might have been looking somewhere else. It's kind of easy to miss. So that would have been just like a nice little touch, not super necessary, but would have helped increase legibility. And then I also would have improved the legibility of these optimal paths one way or another. I think in a perfect world, I would also have some sort of indicator on the pieces that need to be moved to make this optimal path. So in this case, Brian's optimal path, you need to move the capstone over, and then you need to play a flat stone here. And I think having an indicator on the capstone to show that this is a piece that needs to be moved to make this optimal path could be valuable, could be useful information, but it would really only be viable when there's only one optimal path or something like that, because otherwise it would get overwhelming very fast. When you have something like this where there are 3 different optimal paths for blue, you're going to have so many different pieces that could be moved for any given one of those paths that it just doesn't make sense. It would be chaos. There would be icons everywhere. So that's something that I might have played with if I had more time. I don't know if I would have actually done anything with, just because it would be so much information. Again, this is a video where people are being introduced to TAC for the first time. You don't need to give them all possible information. And actually, that's a really important lesson, because one of my earliest forms of this overlay included an additional piece of information, which was how many stones a player has control of, right? So in this case, Brian has control of 4 of Ryer's pieces. Ryer has control of 3 of Brian's pieces. I thought that might be interesting information to convey, because that is an indicator of a player's mobility, how much they can actually propel themselves across the board. However, it wasn't actually vital to understanding what's happening in the moment. That was an indicator of potential rather than current status. And I didn't have any clean way to display that information. And I just felt like ultimately it was going to be overwhelming to a vast majority of the audience and would not have been clear communication. And ultimately that is what we are striving for when we make something like this. It's got to be clear. It has to make sense, because otherwise you're doing more harm than good. So those are just some ideas I have about the board. Hopefully you enjoyed the video. Hopefully you found this at least somewhat interesting. I know I've been talking for a millennia here. If you want to hear me talk more on other things, go ahead and check out my personal channel, youtube.com/@BrandtHughes, or my critical thinking, sciencey research channel, Emergent Beacon. That's youtube.com/Emergent Beacon. Not a lot of videos there, but every one of them is great. Also, of course, if you enjoyed the video that this is based off of, then go ahead and check out Modern Rogue videos at youtube.com/modernrogue. Thanks for watching, and I'm going to stop talking now. Bye.